Welcome to Unit 1, Lesson 3, Estimating Quantities in Scientific Notation. Our learning target for today, I will use numbers expressed in scientific notation to estimate very large and small quantities. And our question of the day, how can you use scientific notation to express very large or very small numbers? Go ahead and pause the video and write down or fill in your powers of 10 chart. Once you fill in the chart, let's compare our answers. I want you to pay very close attention to what happens as our exponents increase in value. What happens to the value of the power of 10? And I want you to pay very close attention to what happens to the value as we are changing negative exponents. We're going to use this information in this chart to estimate different quantities and powers of tens. And to estimate a number using a power of 10, we need to round the value. Then rewrite the value as a single digit times a power of 10. So let's estimate by rewriting this number as a single digit times a power of 10. In order to rewrite this number, it's understood that my decimal point is at the end of this number. And I need to rewrite as a single digit times the power of 10. So that means I will be moving my decimal point over to the left 1, 2, 3, 4, 5 places. So as a single digit, I have 7 times 100,000, which in scientific notation, that would be 7 times 10 to the, how many places did I move my decimal? 1, 2, 3, 4, 5. 10 to the fifth power. Let's look at another one. Estimate by rewriting as a single digit times a power of 10. So it's understood when I have a whole number as such, it's understood that my decimal is at the end of that number. And I would need to move my decimal to create a single digit. 1, 2, 3, 4, 5, 6. Now, 1.923, that is closer to 2 times 1 million. So if I was to write this in scientific notation, I have 2 times 10 to the 1, 2, 3, 4, 5, 6 power. Go ahead and pause the video and make sure you have this one written down as well. Let's look at another one. This time we're dealing with we're dealing with decimal numbers, which means that I must have some sort of negative exponent. So we have to create or rewrite as a single digit times a power of 10. My decimal point is located here. In order to create a single digit, I need to move my decimal point to the right 1, 2, 3 places. And 2.4623 is close to just saying 2 times 0.001. And in scientific notation, I have 2 times 10 to the negative third power because I moved my decimal point 3 places to the right. I am working with a decimal number, therefore I know I will have a negative exponent. Let's rewrite as a single digit times a power of 10. Again, I have a decimal number, so that means my exponent will be negative. Let's see how many times we are going to move the decimal in order to create a single digit. So 1, 2, 3, 4, 5, 6. Now 5.6 is closer to 6 times 0, 0, 0, 0, 0, 1, which is equivalent in scientific notation as 6 to the 10th times 6 times 10 to the negative 6 power. In 2015, the world population was about 7,390,000,000. The population of the country Rhett lived in was about 6,926,000. Approximately how many times greater was the population of the world than the country that Rhett lived in? So the first thing that we would need to do is determine the population of the world, the estimate. So we would need to write the population of the world as a single digit times a power of 10. So the population of the world, the population of the world is 7 billion and 7,390,000,000. So if I was to rewrite that as a single digit times a power of 10, my decimal is understood to be at the end of this number. So I would have 7 times 10. Let's see how many places that I needed to move my decimal to create that single digit. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 7 times 10 to the ninth. And let's go ahead and estimate the population of Rhett's country as a single digit times a power of 10. So that would be, decimal point is considered to be here. I would need to move my decimal 1, 2, 3, 4, 5, 6. 6.9 is closer to 7 times 10 to the 6th power. Now, it's asking me how many times greater was the population of the world than the country that Rhett lived in. So I know that I need to subtract in order to find the difference. So if I was to go ahead and subtract my exponential values, so I have 10 to the ninth minus 6, which is equal to 10 to the third. So it is 10 to the third times greater the population of the world than the country that Rhett lives in. All right, let's look at a different one. Let's talk about scientific notation now. Scientific notation is a shorthand way of writing really large or really small numbers. Scientific notation is written as a product of two numbers. The first number must be between 1 and 10, and the second number must be a power of 10. So to convert a number from standard to scientific, we're going to create a number between 1 and 10 by moving the decimal. We're going to count the number of times you move the decimal. This is the number that will be your power of 10. If your number is greater than 1, the exponent will be positive. If your number is less than 1, like a decimal, the exponent will be negative. So let's convert 1,850,000 to scientific notation. All right, so the first thing we need to create a number between 1 and 10 by moving the decimal. When I have a whole number like this, it is understood that my decimal is at the end. So let's go ahead and move the decimal to create a number between 1 and 10. 1, 2, 3, 4, 5, 6. And 1.8 is between 1 and 10. 1.85. Count how many times you move the decimal. I move my decimal 1, 2, 3, 4, 5, 6 places. So if I was to write this in scientific notation, my answer would be 1.85 times 10 to the 6th power in scientific notation. All right, let's look at another one. Let's convert this decimal number to scientific notation. The first thing that I would need to do is create a number between 1 and 10 by moving the decimal. So I have my value here. My decimal is on the left. I am going to move my decimal to the right to create a number between 1 and 10. 1, 2, 3. 7.826 is a number between 1 and 10. And count the number of times you move the decimal. This number will be the power of 10. 1, 2, 3. I moved it 3 times. But notice here, if your number is less than 1, like a decimal, which it is, the exponent will be negative. So this would be a negative 3. And if I was to write this in scientific notation, I would have 7.826 times 10 to the negative third power. Let's write it over here. Let's erase and write it over here. I would have 7.826 times 10 to the negative third power. And that would be my answer in scientific notation. All right, let's look at why does a negative exponent give us a small number? Now, if you look at this number here, I have 10,000. 10,000 is the same as saying 10 times 10 times 10 times 10, or 10 to the fourth power. 1,000 is the same as saying 10 times 10 times 10, which is 10 to the third power. Now, as you see that I am decreasing in exponential value, or in my exponent value, my value is also decreasing. When I get to 10 to the 0 power, my value is 1. So with this pattern, let's see what happens when we move to a negative exponent. So when we move to a negative exponent, we are left with 1 to the negative 10, 1 over 10, 100 over 1 over 100, which equals 1 over 10 to the second power, which is the same as saying 10 to the negative second power. So let's convert 2,850 to scientific notation. It's understood that my decimal is at the end. I'm going to move my decimal 1, 2, 3 places to the left. So I have 2.850 times 10 to the third power. Let's work backwards. Let's do it the opposite way. Instead of convert it to scientific notation, let's convert to standard notation. To convert from scientific to standard, you're going to move the decimal the same amount of places as the exponent. If the exponent is positive, move the decimal to the right in order to make the number larger. Add zeros as placeholders. If the exponent is negative, move the decimal to the left in order to make the number smaller. Add zeros as placeholders if needed. So if we are trying to convert 7.83 times 10 to the 7th, I am going to move the decimal the same amount of places as the exponent. So if I am going to move my decimal, I have 7.83, and I am going to move my decimal 7 places to the right to make the number larger. So it would look like 1, 2, 3, 4, 5, 6, 7. And I would go in and add zeros as my placeholder. So my new value would be 78,300,000. Let's look at another one. We're going to convert 3 times 10 to the negative third power. Now, because I am working with a negative exponent, I know that I will have a smaller decimal number that will be my answer. So if I had 3, it's understood that my decimal point is there at the end of 3, and I am going to move a negative 3 places. So I am going to move to the left 1, 2, 3, and add my placeholder. So my value would be 0.003 in standard form or standard notation. Let's look at one more. I have 9 to the negative second power. I'm working with a negative exponent. So that means that I will be moving my decimal to the left 2 places, 1, 2, and I would need to add a 0 as my placeholder. So my new value would be this. All right, that concludes our Unit 1, Lesson 3, Estimating Quantities in Scientific Notation. You will have some practice problems to complete. If you have any questions, please feel free to contact me on Google Classroom or Remind, and I'll be more than happy to assist you. Hope you guys have a great day, and I'll see you next time.